Osmotic fragility of red cell. One important quality of plasma is osmolality. Normal plasma osmolality is 280 to 295 millismol per kilogram water. One important cell in the blood is red blood cell. Fluid movement in and out of red blood cell depend on plasma osmolality. If plasma osmolality decrease, more fluid can enter to the red cell. If more and more fluid enter to the red cell, it can blast. Red blood cells' ability to resist in osmotic gradient is called osmotic fragility of red blood cell. It's an important quality of red cells. With some defect in the red cell cannot stand with slight osmotic changes in its environment or in the medium. Or it can be opposite. With the defect in the red cells, it can resist in a higher osmotic gradient than the normal. So osmotic fragility tests can be used to detect red cells with certain defect. Here is a demonstration of red cell osmotic fragility test. Osmotic fragility test of red cells is not a very important test nowadays due to some advanced hematological test. But this experiment teaches us very important physiological principle, osmotic fragility or osmolality. For this practical, we need to collect some blood. So 2.5 milliliter anticoagulated blood and 12 test tubes and sodium chloride preparation and centrifuge. Those are the main things we need. Here you can see 12 test tubes, 0.9 gram per deciliter sodium chloride. Each tube contains 10 milliliter of sodium chloride solution in different concentrations until 0.1 gram per deciliter. Then we add 0.1 milliliter of blood to each tube and centrifuge tube. After that, some tubes looks very clear like this, and some tubes are reddish in color, suggesting hemolysis. We'll have a look each and every tubes. 0.9 gram per deciliter tubes, very clear solution, and the deposited red blood cells in the 0.75, again very clear, and deposited cell in the bottom, and 0.65 very clear, 0.6 again very clear, and 0.55 you can see reddish color in the tubes when it compared to the previous tube. So it's a very clear color change in the tubes with 0.55 gram per deciliter. And the next tube, more color intensity, so more hemolysis. So here you can see where the hemolysis start in the tubes with the 0.55 sodium chloride concentration, and then the hemolysis increase with the reduction of the concentration, increase color intensity in the next tubes. And here 0.4 tubes, and still there is some deposited cells in the bottom, and the next tube 0.35. This is the tube with 0.35. You can see the no color intensity different and no deposited red cells in the bottom, the tube with the 0.35 concentration. Here you can see where the hemolysis start and where the hemolysis ends. No deposited red cell in the bottom. Condition that increase the osmotic fragility of red cells: spherocytosis, autoimmune hemolytic anemias. Condition that decrease the osmotic fragility of red blood cell: sickle cell anemia. Here you can see the same test, osmotic fragility test, done blood with increased osmotic fragility. Here the lysis start early in the tube with 0.75 mg per deciliter sodium chloride concentration.